66 million years ago, a rock the size of a city traveling at roughly 20 kilometers per second hit the coast of what is now Mexico. The impact released more energy than 1 billion nuclear bombs. The sky went dark. The temperature dropped. More than 3/4 of all species on Earth vanished within a geological instant. And from that catastrophe, eventually came you. But what if the rock had missed? What if, by the smallest change in trajectory, the asteroid had sailed past Earth and continued into space? What if the dinosaurs had never gone extinct? This is not just a thought experiment. It is one of the most revealing questions in the history of life on Earth, because the answer tells you something extraordinary about how evolution actually works and why the world you live in is far more fragile and far more unlikely than you have ever been told. Start with what the world looked like 66 million years ago, just before the impact. Dinosaurs had already been the dominant land animals on Earth for roughly 165 million years. To put that in perspective, the entire span of human existence, from our earliest ancestors to right now, is less than 4 million years. Dinosaurs ruled this planet for more than 40 times longer than that. They were not a temporary experiment. They were the most successful large animal design in the history of complex life. And they were not the lumbering, slow-moving creatures of older science. Paleontologist Robert Bakker, whose work in the 1960s and 1970s fundamentally changed how scientists understood dinosaurs, demonstrated that many species were warm-blooded, fast-moving, socially complex animals. Some hunted in coordinated packs. Some migrated in herds of thousands. Some cared for their young in ways that resemble modern birds more than modern reptiles. Because that is what birds are. Birds are dinosaurs. Not descendants of dinosaurs. Not relatives of dinosaurs. They are a living branch of the dinosaur family tree that survived the extinction event, adapted, and are now represented by more than 10,000 species, flying, swimming, and running across every continent on Earth. So the question of what would have happened if dinosaurs never went extinct is really asking what would have happened if the non-avian dinosaurs, the ones that did not survive, had continued. The answer requires understanding something fundamental about evolutionary pressure. Evolution does not move toward a goal. It does not have a destination. It responds to the environment that currently exists. When the asteroid hit and the world changed catastrophically, the small, burrowing, warm-blooded mammals that survived did so not because they were superior to dinosaurs. They survived because they happened to have the right characteristics for the specific nightmare that the impact created. They were small enough to hide underground. They could survive on insects and seeds when larger food sources collapsed. They could reproduce quickly enough to recover from population crashes. Without the impact, those same mammals would almost certainly have remained what they were. Small, nocturnal, ecologically marginal. For 165 million years, mammals had coexisted with dinosaurs, and for 165 million years, they had stayed small and largely irrelevant. There was no evolutionary pressure pushing them toward larger size or greater complexity, while dinosaurs occupied every major ecological niche. So in a world where dinosaurs survive, mammals do not take over. They remain in the shadows. And the large ecological niches, the grasslands, the forests, the open plains, continue to be dominated by dinosaurian forms. But what would those forms look like after another 66 million years of evolution? This is where the science becomes genuinely surprising. Paleontologist Dale Russell, working at the Canadian Museum of Nature in the 1980s, studied a dinosaur called Troodon. Troodon was a small theropod, roughly the size of a human, that lived in the late Cretaceous. It had forward-facing eyes, giving it stereoscopic vision. It had grasping hands with an opposable thumb-like digit. It had the largest brain relative to body size of any known dinosaur. Russell modeled what Troodon might have evolved into over millions of additional years of selection pressure, and what he produced has become one of the most famous thought experiments in paleontology. A bipedal creature, upright, with large eyes, a rounded brain case, and manipulative hands. Something that looked, in general body plan, startlingly similar to a human being. This is not science fiction. It is the application of genuine evolutionary principles. When environmental conditions favor intelligence, stereoscopic vision, upright posture, and manipulative appendages, evolution tends to produce versions of those traits across wildly different lineages. This pattern is called convergent evolution. It is why dolphins and sharks have similar body shapes despite. But they would look at the world through eyes shaped by a completely different evolutionary history. They would have scales rather than skin. Their bones would be hollow. Their metabolism would run differently. Their emotional lives, if they had emotional lives, would be built on a foundation that diverged from our own 320 million years ago, when the ancestors of mammals and the ancestors of dinosaurs split apart. Now consider the implications for intelligence itself. If complex intelligence can evolve in two completely different lineages, in both dinosaurian forms and mammalian forms, what does that tell you about the universe? Astrobiologist Simon Conway Morris at the University of Cambridge has spent decades arguing that evolution is not random in its outcomes, that the universe is full of what he calls evolutionary attractors, certain solutions to the problem of survival that keep appearing across different lineages because they work. Eyes, wings, intelligence, social behavior. These are not accidents. They are, in Conway Morris's framework, almost inevitable outcomes whenever life achieves sufficient complexity and faces sufficient selective pressure. This means that in a universe of hundreds of billions of galaxies, each containing hundreds of billions of stars, many of which have planets, intelligent life may have evolved not just twice, as our alternate Earth suggests, but countless times. In forms we cannot yet imagine, built on biochemistries we have not yet mapped. Looking at the cosmos through sensory systems, evolution has not yet shown us. You are here because a rock missed a collision with Earth 66 million years ago, and instead struck it. You are here because small, nocturnal, ecologically marginal mammals turned out to have exactly the right traits to survive a catastrophe that killed almost everything else. You are here because 66 million years of mammalian evolution, unimpeded by dinosaurian competition, eventually produced primates and eventually produced you. In the alternate Earth, the dinosaurian intelligence looks up at the same stars you look up at. They ask the same questions. Where did we come from? Are we alone? What would have happened if something had been different? And in their version of the question, the something different is the rock that hit. In ours, it is the rock that missed.